Okay, so welcome to my presentation. It's a presentation from me. I'm Fabrizio Bitti. I'm from Italy. I work with Delphi since I was a small boy. So now I am a grown-up boy in both sides, in both directions. So I am the CEO of Big Time Software, the Italian representative for Embarcadero. In Italy, we take care of licenses and training and events, and we organize also the IT DevCon conference in Rome, which is going to be held in November this year. So anyway, why this speech? Okay, it's very important to understand that if you are sitting here talking about blockchain, you probably love money, okay? A lot of people talk about blockchain and bitcoins and money, okay? So that's why I'm here, because blockchain is very popular. Everyone talking about blockchain. Blockchain, what I see in the marketing, okay? Now is happening with the AI. So they sell the same stuff as before, but they put AI in the title, and people seems to be more interested. The same thing's happening with blockchain, okay? With cryptocurrency, with all these terms that people don't really understand. And then they start to become a good wave of marketing activities. So blockchain is popular, blockchain is used for cryptocurrency, which is true, okay? The cryptocurrency is money, and money is good, okay? But it's not true. I didn't make this speech for the money. I made this speech because I wanted to understand what is a blockchain. Everyone talking about blockchain, okay, what it is. It's very important to understand that for a programmer, the real way to understand something is to write a program that make it, that work with it, okay? So when you write the code, you actually breaking up the bits and pieces and you really understand what it is, okay? So let's talk about blockchain, what it is, the blockchain. It's very important to understand that blockchain is not exactly something that is money, is not cryptocurrency. Blockchain is just a data storage way, okay? It's a way to storage data. Is an array, is a linked list, is a way to store your data in a structure, okay? But this structure, it has some advantage, okay? One is trust and transparency. So everyone can read the blockchain, read the data in it, and trust that that data, it is official, correct. Everyone can have his own copy of the blockchain and check if it's correct. If what's inside is exactly what it should be inside. Okay, and nobody can change the data in it. It's easy to maintain because everyone that has a Bitcoin portfolio, for example, on his computer, you have a copy of the full blockchain. Okay, you have a copy, and you are actually easily holding all the transaction happen in the history of Bitcoins. Okay, so it's cost effective. Everyone with a computer can have it, can have a copy. It is unbreakable in the terms that, you know, like every lock, the cost of the lock that you use for closing something must be related for what you are closing with. If you are closing a pack of candies, you don't spend $2 million on a lock, okay? So depending on what is the value inside, and so basically the blockchain is virtually unbreakable. Then the availability, everyone can have it, is decentralization. So you don't have one single point of holding the data. Everyone has his own copy. And so within the blockchain, there is a lot of features that are specific to the blockchain, but they are not, obviously a database is another way of holding data. And then there are other ways to hold data. Blockchain is one of the way, okay? So blockchain is a distributed data structure, okay, where change in any of the block will invalidate all the blocks after, okay? So you can be sure that you can check that all the chain is correct with virtually no cost to check if everything is in place. But if someone goes there and change it, for example, that you give the money to me, and then instead of giving it to me, you give it to someone else, then this will invalidate all that block and all the block later, okay? We will see how it works, because, explaining like this is important to get some information, but you need to understand exactly how it works. So, we know that is a way of storing data, but what is not? The blockchain is not Bitcoin. Bitcoin is a way of exchanging a virtual cryptocurrency value, but it is all the information of the history is held in a blockchain, but a blockchain is a structure of data. It's nothing to do with what's inside the data, okay? It is not unbreakable, as I told you. It will be possible to break, but it will cost you a lot of money. It's not centralized, so there is not one copy, one silver or gold copy of the blockchain, and it's not cheap. So to make a blockchain, it will cost you money to actually mine the blocks. We will see how it works. And it's not controllable by any single user, okay? So there is no people, one single person that can decide to change the full blockchain if it's a blockchain shared between people, okay? How is made? So a blockchain, it is a chain of single blocks, okay? Within one block, there is the data, and then there is the hash of this block. Then, on the linked subsequent block, there is a reference to the whole block hash. Okay? So when you chain this, it's like a chain, This is linked to this is linked to this, and this will be linked to the next one. Okay? So if you put data, store data in it, but if you change the data inside, you will change this hash, which means that this is no longer valid, and all the subsequent blocks will be invalidated, will not be valid. So if you try, there are hackers trying to hack the Bitcoin blockchain. They try to put a new block, and this block will just cost a lot of money to produce. They produce one block, but then the community, the full sharing, the people sharing the blockchain will just refuse that block, because that block is no longer valid with all the other subsequents. Okay? So what can we store within a blockchain? We can store whatever we want. In the case of cryptocurrency, sorry, this is moving. Okay. Can you hear me? Yeah. Okay, so in case of cryptocurrency, you store the transaction. Okay? So for example, X paid $100 to Y, and then in another block I can get 2 or 3 or more transactions. This is actually what happened in the Bitcoin blockchain, okay, where there are sort of transaction, a number of transactions in each block that take count of how many Bitcoins Mr. A transferred to Mr. B, okay, or Mr. Let's say the wallet A go to the wallet B, okay, and then you have the numbers. Obviously, if you want to know how much money there are in one wallet, you have to go to the start point of the blockchain and read it all the information to get how many Bitcoin are in each wallet. Okay, and you have, it is public. You can go and download the blockchain, and then you can read and understand how many transactions are happening every day, and why there are some days where there are more transactions. You can do analysis, you can see everything. You just see that wallets are, you know, a big hash number, but then apart from knowing who is behind that wallet, you know exactly all the transactions that happen in the blockchain, okay? So blockchain is just a data storage. Okay, so we'll see. So I started to, okay, I want to, I was reading different implementation of blockchain in C++, in JavaScript, and other languages. So I decided, okay, I need to make one that is in Delphi. Okay, so I start to write simple code. So a class, a T block, can you see, more or less? Yes. So in a T block, I just have the data, which is the transaction data or whatever data I want to hold inside my block. Then there are some information like the time when the data has been produced, when the block has been produced. Then there is the index, these F knowns, which is the key of the mining for the blocks, okay? I will explain you now how it works. So this number that is there is the only number in the world that gives me that exact hash produced for this block. So that's the difficulty thing that comes out. So anyway, I have some methods to build, construct, get information from the block. Then we have the chain. So the block is a single block, but we need a class to manage the chain. So the chain, I just put it a simple array of T block, okay? So it's for the sake of demoing, understanding. So a chain is just an array of blocks, okay? But we need to get information about the blocks, and then there is a add block procedure, which is the one that for adding the block will actually try to find the right F knowns data to keep inside. Okay, so the key point is when I create a chain, there is always a seed block, the first block of the chain, okay? Which need to, obviously doesn't have, it has a particular thing that doesn't have a reference to a previous block. It's the only one, okay? So everyone needs to agree on the first block. Okay, so you have a chain and the first block. Then you have the add block, which just try to get the hash and mine the block, and then it will add it to the chain. Okay, so it will do a set length, so we'll add one element to the array and then put the block inside the array. Okay, let's see it in Delphi, not on the slides. Okay, so I removed the glasses because I'm over 40. So we, I will make it a little bigger, if I can. Okay. So we'll see, we have a block, which is here. It's a little bit different from what was on the slides, because I worked a little on the night to make it more appeal. Okay, so what is the key point? Here's the main block, okay? The one that we were saying. So the main block is actually trying to find a hash that has a particular starting with the number of 0 that is specified into the difficulty level of this chain. Okay? So you will try to calculate the hash with this, okay? Then we'll check if the hash calculated is starting with a number of 0 that is the one in the difficulty. So for example, now I think we are in difficulty 5. So if the hash starts with 50, it will be a valid hash. Okay, now is starting with 50. Obviously this can be, you need to start with this kind of starting point. Okay? So you can change this part, but what it does is actually changing the number. I'll show you how it's doing the calculate hash. Okay? The calculate hash gets the index of the block. So if it's first block, block 2, block 3, etc. Then the daytime when the block has been created. Then it takes the data, which is the data stored, and plus a number, okay? Just a simple number that is 1 to infinite, okay? To whatever can contain an int. And this number plus the previous hash, it gets the full string with which we use, so this SS, we use to get the hash of this big string. Okay, so it is the hash code for our data, okay? And this data include this number, okay? If this data, when I calculate, if this data is not containing a number of 0 at the start, I will just increase the nonce and try to calculate again. Okay? So these things can happen millions of times. But when you start, you have all the data inside, and then you have this unique number, the F nonce, and this unique hash that is calculated on the data. Then it's very easy to calculate the other way around, so to check if the data will give me this hash. Okay, yes, the hash is correct. You remember when there was the X on the hash code. So I can check the hash of the block to see if the block is valid. But to calculate that hash with that particular number that goes into the calculation, it will take time. Now we are using 50 at the start, which will take about 3 to 5 seconds. If I increase to 6, you will get 30 to 50 seconds. Then if you increase it to 256, okay, it will take you days to calculate the right hash. Sometimes it can happen that you calculate and you get the number of 0 that you want in 5 seconds. It's just luck, okay? But sometimes it takes you longer and longer, okay? So that's why they are doing the calculation of they call it the mining of the block, which is actually this way of calculating with the number inside the calculus, okay, that it gives me this result as the first part of the hash. So this calculation, it takes a lot of CPU time, okay, and a lot of electricity to calculate if this number is very big. That's why there are pools to calculate, but we will talk about that later. Okay, so I show you a very simple form that I created. Okay, so this is a form, this is a memo with which is our log. This is on create of the form. You know, on the form create, I just create my blockchain. Okay, and then I will write here the information on the memo. What does the blockchain create? The creation of the blockchain is set in the length to 1, and then create the genesis block, which is the first block, okay? And then it will set the difficulties of this chain to 5. If we change it to 6 or 7 or 8 or 200, it's different. Okay, so the difficulties is a chain property. Okay, so every block within that chain will have the same difficulty level. Okay. Okay, let's have a look what happened in debug mode. Okay, so I start. First, we will create my chain and write here, okay, blocks in 1, chain 1, last block's genesis block. Now, I can show you what I can do here. Wait, I put a breakpoint. Okay, I get some, I'll show you first how it works and then we go into it. So, this is the Delphi Summit Data 1. Okay, I do mine nest block. You will do the mining. I don't know if you can read it. I can read it to you. It took 0 minute, 1 second, and 302 milliseconds to have unknowns. That number, you know, that number to obtain the first 5 digit of the hash as 0, it is 723,910. Okay, so if I go with data number 2, I do minus block, and you will have now is much shorter, so we only have 171,000 times. If I put number 3, this time 635,000. Okay, so it is completely random. Okay?
But related to the difficulty.
Yes, yeah, always related to the difficulties, but sometimes you see now it's 3,300,000. So sometimes it takes longer, sometimes it takes shorter. Because what it does is actually, I'll show you in the mine block. Okay. I'll show you what happened behind the mine nest block. So what it does is take the 50 string, which can be your name, which can be whatever you think of. Then I do calculate the hash. The hash inside as F5, F2, 1, so this hash is not good. And the knowns number is 0. Okay? So, then there is a process message, but, okay, now I try with 1. I calculate the hash, and the hash is this. And now is 2, and I calculate the hash. Can you see? So, the 6, I don't want to go in debugger for 3 million, but just to make you understand what is happening behind. So it will just go and calculate the hash. This took 600,000, okay? Now it took 220,000. So what's inside the chain? I can read the chain. I see that I have block 0, etc., all the information, and I can check the integrity of my chain. So wait, I open. Okay, so I see here my chain that is as a genesis block, which has no previous hash. Then there is the block number 1 with this hash, and then the block number 2 that has a previous hash, that is the block before, and then all the information inside the data field. Okay, so these are all data related one to another through the previous hash information, so this information. Okay, I'll show you what happened inside. So go here. When I go here reading the chain, I just okay, so I get the length, I do a for, and I read the information in my chain get data. Okay, and I say get data 0, 1, 2, 3, 4 information. What does this? This just go inside the blockchain, and we'll get the chain data, which is a string for our purpose. Okay, the chain data has been defined here in the block, and it's a string. Okay, so I get the information from the chain, asking, can you give me the block number 1 and then the data, and I will get the data. Give me your question.
Excuse me. Maybe you will answer this question later. But why putting this constraint of having 50 at the beginning? Why not getting the hash, simply getting the hash?
Yeah, because yeah, exactly.
With 50, 60. What?
This is the key point of a blockchain, which means that 50, I put a 50, but you can put your own hash of 256 or whatever at the start, okay? Number of bytes at the starting point. So it means that you need calculation time to insert something into the chain, okay? But you need 0 calculation time to check if what's inside is correct. Okay, so you just put, okay, I want whatever hash code that give me this first part. And that, to calculate, there is no way back. So you can only calculate and check if the result is that. And that's why the blockchain has a security level, because it needs to add a block, it needs to calculate. Obviously is counter, you know, is not efficient. It will be more efficient having a normal hash, but then I can go there, change it, put the new hash, that's it.
No, because the chain must remain the same.
Yeah, but I can calculate all the chain in at the back and create
so
a new chain with
relies on the time for calculating. Is that correct? The security?
Security is exactly the time you need, the CPU time you need to calculate one block, but not only one block, but all the block that comes later.
Okay.
So if you want to change something, you have to go and change all the chain from there to the end.
How secure is this with quantum computing?
Sorry?
How secure is this with quantum computing?
Quantum computing.
Yeah, because in that case you can try
I can tell you
several.
yeah, but I can tell you that there are server farms, actually GPU farms, big as this building.
Right now, right
Yes.
now. Yeah, but that's it's a
Yeah, I
bullshit.
mean, if you obviously if you reduce that to few
Yeah,
seconds,
then all the security.
then the old security is gone.
Yeah,
Of course.
and probably that will be.
Yes. There is another part which I didn't, obviously, because I'm alone. I'm not in the community. The other part is the credibility of a node and the sharing of new. Every time a new block is inserted to the chain, it needs to be validated by many others, and not everyone has the same weight in the community of the blockchain holder. Okay, so there are some sites that have more credibility. Okay, so you need to be every block need to be validated by more than one. So, for example, if I receive a new block, I said, okay, who's this block from? I got it from you. Okay, I check, do you have this block? Do you have this block? Do you have this block? If no one else say that has that block, I just refuse the block to add it to my chain. This is the way it works.
So you say there are additional steps for increasing?
Yes, yes. But the first step of the blockchain is the time for calculating the right hash. Yeah.
Yeah, just to point to just verify. So the nonce, it's called, yeah, determines how many time I have to rerun the hash and like how many hashes of the hashes within one procedure, within one block.
Yes.
And the amount is determined by the first
digit. The first digit of the hash. I want the first digit of the hash to be 50 in my case. Okay, so the 50 in the hash are determined by that number, which is increased.
Yeah.
I can do different. Instead of increasing, I can start from 100 millions and go back, or I can get random numbers, or for example,
The other just point. So if I need to store this, the whole chain, so I need also, it's not to store the hashes, I need also to store the data. The hashes is only to verify if this data is valid or not.
The actual block is not only the data. The block is the data and the hash and the previous hash.
And the previous hashes.
So all this information together, it gives you
So using Bitcoin, for example, if I download the whole
chain,
I can actually check the data of each transaction, how many.
Since the start, since the Genesis block.
I can know, for example, the amount of money being transferred from which wallet to which wallet,
yes.
using
the amount, not the money, the amount of bitcoins.
Among the.
Exactly. The amount of bitcoins, which at the start they will value about $20 each. Yeah. Okay, so one Bitcoin was $20.
So if they
now
figure
60,000 euros.
Yeah. So in principle, if this was figured out somehow through quantum computing, I know that currently it's not yet been figured because they couldn't. It works in different principle. But if this was figured out through quantum computing, I think it's not only Bitcoin that will crash, even the banking system.
Yes,
we have to use cash again.
Yeah, I mean all the encryptions, all the encryption goes.
Not all, but but that idea about the amounts of zeros is that just your implementation?
Yeah, it's just my implementation. It's my implementation. They can have you can have the starting hash point, the starting part of whatever you like.
But I can also say, hey, I want 5 zeros at the end, or some whole kind of different.
So
exactly. Blockchain implementation has its own way of.
And also the that number that I have and used is my implementation. So they can have a different way to do in, I don't know, a string that is a representation of hexadecimal something that put in the string, whatever.
Or you want the text, this is cool at the front always.
Yes, exactly.
You can think whatever you want.
Yeah.
Just quickly, we are going to discuss Web3, and because I know Web3 now relies on the blockchain in terms of coding or getting domains or whatever. This is the new thing that is being discussed everywhere. It uses blockchain instead of the conventional domain.
Yes.
Are we going to discuss this? And the second thing is that can this be indexed? For example, if I want to look up for a certain amount, I have to search, or sorry, a certain record. I have to search through the whole blockchain.
Yeah, I mean, it is the blockchain is a chain. Is like a linked list. Not double linked list. It's a linked list in one direction only. So the way to navigate it is this. But nobody is preventing you from reading it once and put it into some index and do whatever you want. You know, it's data. So
search.
yeah, you can then read once and then index it by hash or index by amount, index by. You can do whatever you want. Okay,
and this is how Web3 should work, or because you have to query some information from the Web3 blockchain.
Yes, yeah. I mean, for example, there are websites and services that give you information on the Bitcoin blockchain. So if you want to search for a certain wallet and say, okay, let me see all the transactions in this wallet, they will give you in 0 time because they already got everything and index.
Yeah.
So they can, and it's public. So that information is not held by any entity. You know, it's publicly available. Okay. So, sorry. So we have seen this. That we have seen how to create to mine the block. Then I was there and thinking, but the real life is if you are doing the mining, there are pools in the mining of bitcoins. What it means pools? It means that we are searching for a certain hash for validating a block. Okay? To be validated, you need to calculate these big hash numbers, and it will require a lot of the CPU. So what happened is that they give different part of the searching of the hash to different people, and they say, okay, you start searching from, let's say now that I have the number, you start searching from 1 to 50,000, you go from 50,001 to 100, you go to 100 to, okay, and we all together start doing the search. The first one who got the right hash, he will communicate to everyone and say, hey, I got the hash, so he will get a prize and he will get the money on it.
So you share the mining, is that correct? You share
Yes,
the mining.
yeah, exactly. So what I did is I created another project which is actually threaded mining. Okay, so yeah, this is not the same as before, but yeah, I show you the important part. So this is using the same block and blockchain. Okay, you see the same unit as before, but I created this threaded block. Okay, so what it does is a new block derived from T block, okay, that has the ability to do the mine block, which is the same method as before, and this will just create a certain number of threads. Every thread will be created, and then I will wait for all the threads to end, and if I found the hash, I will exit. If not, I will start again and creating another 10 threads, doing the same search, and then waiting for the information. Okay? So, just to show you. Oh, I think, oh no, yeah, wait, I changed the difficulties of my chain from 5 to 6, okay, to have just a little more time to see what happened. Okay, so I start mining the block. Oh, this doesn't have the Skia animation. Sorry. But you see all the threads that are created and destroyed. They are searching for a bigger number because it's a bigger difficulties. All the time that they all finished, it will delete all the threads and restart another 10 threads. This is not efficient. There will be a lot of ways to do it better, but just to give you, yeah, you see information. This is 24 million is the number needed as F1s to get 60 as a starting of the hash. So it's just the number. Though this number, 24 millions, we will, it was calculated by calculating 595,000 hash per second, okay, as an average. So it's a big calculation of hashes. But yeah, if you start, you see again all the threads going and the information. So the part that is changed is just when I go here and do the, you see, when I do the add block, the only difference from the code before is that now this block is a threaded block. So the threaded block, you will just call the mine block method, which is different from the block, from the threaded block, create this number of threads. So it is actually working in polymorphism way, okay? Using polymorphism of the language. So I just call in the add block, I just call the same as before mine block, but now because this one is a threaded block, is actually calling the other mine block. So this mine block was from the block, and this was the simple one, okay? Because now I created a threaded block, I have this. Wait. I close a little bit so you can see. I have this method to calculate the block, which creates actually a number of threads, which is 10, but you can increase it to, I tried with 500 threads. It will work. It is still working, you know, it depends on your machine, but it will work. The work it is doing is not that heavy, okay? The calculation of a hash is not that, the most of the time is actually reading and confronting strings. So that's the real, and then creating the hash, and then after the hash, checking if it's correct, and then increasing the number there. Okay, so I will, is it working? Have you seen this? What happened? Oh, okay. I made some mistake with the event probably. This found event was deleted somewhere, and then now is, I don't know. Okay, anyway, this is the, come on. Okay, there's no way. Yeah, I made some mistakes in the in the multi-threaded environment. Yeah, so this found event, I set this event and I created every time that I start doing the mining. I have it. Where is the event? No, it's here. I don't remember where I have the event. Threaded block, yes. Oh, yes, I created here, but then here was, in the other one was gone. Yeah, maybe I finished in the other one, the other thread, and closed the event, and then there was still this mining block was still running, and then didn't find the event. But okay, I need to protect that. Anyway, this is what it was doing. It was actually creating blocks of 500,000 number to give to each thread, and they will start doing the search. Okay. Now go back to the other project. Okay. So if I start the change the difficulties of my blockchain to 6 or to 7, just to show you that it will take time with just 7. Okay, so if you change it to a bigger number or to a bigger starting point, it will take a lot of time. And this time is the protection of your blocks. Okay.
We can even imagine if you cannot find that constraint, that number, that hash code with that constraint. If you say put, for example, for a string of possibly 100, and you say I want the 51st character being 0, it cannot find anything.
No, there will be a number that gives you that. There will be. It's a number or a string that will give you that. Okay.
The string is a length defined, the string, the hash string.
Yes.
Okay.
Yes.
Say it is 100 characters.
Yeah, because I use this kind of hash. Can you imagine having a bigger hash?
Okay.
Okay. And then having certain part that I want to be that.
But it can be possible not to find the hash having that constraint. Just guess of one simple solution. You have a string, hash string of 100.
Yes.
You say I want to have 99 0.
Oh yes, of course, of course.
It's a constraint.
Yes. It depends on the length of the hash and the way it changes.
Yeah.
But obviously, when you are planning your chain, you have to understand what are the possible hashes and the possible solutions. Obviously, it cannot be with a hash like this. You cannot have difficulties that is, so too close to the length of the hash. Okay. Okay. So, other questions? Yes.
Yes, so the structure is basically parent-child. What prevents me from creating a tree instead of just a chain?
It prevents you the fact that you will have to can invalidate one single root of the tree, and it will be easier to manipulate. So if you have a chain and you go in the middle, then you have to calculate all the others to have another chain that is valid. Okay?
Yeah, but I could create a block based on any previous block.
Yes. Yeah. You know,
The tree then would still be valid.
And it's even as secure.
yeah.
Because they will inherit from that same hash.
Yeah, instead of you create a block tree instead of a block chain. Yes.
That could happen.
Yeah, that could happen. I cannot see that. I don't see that they are using it for storing something at the moment, but maybe if there is, why not? It's the same concept. The point is that validate the single block based on the previous. And you will, if you want to attach something else, you can do it on this one because this is valid. And then you can attach. Obviously, you can attach more than one to a single, which means that I can go and attach anything on any other and I will be valid. If I can always be the last one. But, yes?
Can this technique somehow protect us against fake news? Or
Yeah, I mean, if the point is, who is the community holding the right, the correct news, who does the check to check if they are correct, you know. The power of calculation, so the amount of money you need to spend in electricity to calculate the hash doesn't stop a fake news producer to actually do it. So I don't see that's another story. It's about trust. It's about trust of people. Yes.
Sorry, I have no experience actually with the blockchain, but I have a question. Is it reasonable to include the previous block hash into calculating hash of current block?
Yeah, it is. Oh, it is. It is. It is needed.
Okay.
It is needed because if you don't put that, then you can have a proper block and attach it to everywhere you want. So it is included. The previous hash is included in the calculation. Oh, it finished. It takes 146 million to arrive there. Okay? Yes.
you found that nonce now, so what you can do next with it? You can change data, create new block?
No, once you have mined the block, so once you have the number, you have the hash, you are certifying that that block is correct and is in the chain because it has a reference to the previous. Okay, so the mining and the nonce number, it is what is like a stamp, a final stamp on your block. So your block is closed, and now you can distribute it to others to check that is correct, and everyone else will agree on that, because if they just do the check, with this number inside, everyone can do the... We haven't seen this part with this check integrity. Okay.
So what's now reward for you because you found it?
Oh, here nothing, but in the Bitcoin, when I do a transaction, when I want to send money to you, I say, okay, I send money to him, and I'm ready to pay this amount to have this transaction certified. And bigger is the amount that I put, and my transaction will go higher in a priority list to be found, to be included in the next block, which will be validated. Okay, so if I say I want to send money to you and I put very low amount or no amount, I want it free, my transaction to send money to you will just go and stay lower in the priority and will never be included in any block.
So
people that
will never be done.
will never be done. It will stay there forever, basically. If you put a low amount of money, that transaction will never be executed, will never be inserted into a block, and then that block closed and certified. Okay? So what you do is, because I want to send money to you because you have to give me a service or whatever, so I will put a reasonable amount or a little bit more if I want to be quicker, so that my request of transaction will go on the next block, and all the money that people is paying for that block will be rewarded to whoever found the hash.
But
okay, that's what mining, making money with mining is doing. Is actually getting the transaction fee from the people who move bitcoins.
But the Lightning Network, how does that work then?
Riccio.
Oh, sorry, it's time.
5 more minutes.
5 minutes, okay, go. Sorry.
The Lightning Network, because this can take a lot of time before the transaction is accepted or added to the blockchain. It can take days or whatever, but the Lightning Network, I don't know how it works, but
no, I don't know
it's
either.
there to get those transactions done almost immediately.
I don't know that.
Okay.
Sorry.
I have one more question. What if two transactions are basically requesting a new block simultaneously? What if the first block gets done? Does the other block need to be done completely?
No, I tell you. Within a block, there is more than one transaction. Okay? So one block contains 100 transactions, for example. And that 100 transaction that goes into the block, it will be decided by a priority based on the amount of money that people is paying. So there is one block every, I don't know, every 10 minutes, let's say, okay? So every 10 minutes, all the transaction that has a high priority will go on that block.
Within the block, that block is processed.
Yeah, that block is processed. When it's closed, and then the new block we can.
Okay, so no block is ever done
twice.
Simultaneously.
No.
But who decides this? Because it's a decentralized.
Sorry?
It's a decentralized algorithm, decentralized.
Yes.
Software. But there is a centralized service who defines that order and who assigns those transactions to be processed.
Yes, it is actually sort of, there are multiple entities that can do that. You can even be yourself to receive transaction, to create a block, and propose the block to the chain.
But then you can get the situation that
yes. The point is that there will be, then only one will be valid, because the one who got the first, then will be the one valid, and the other one will be discarded.
And they have to start over.
Yes, exactly.
That was my question.
Yeah.
No, okay, sorry. So, but what happened is not that two blocks are inserted into the because the first one who arrives gets the transaction and is closed, and that one will be the valid one. Okay?
Yeah.
Yes.
Could it ever happen that a chain is temporarily split into two branches and later merged in a controlled way into the main?
No, it's not on SVN or on Git. No, it's not. In the sense that once we have the block there, after that there is only one block.
Yes,
okay, and that when there are people trying to, I told you, hackers and people trying to attach blocks but that will be discarded by the community.
The community takes care of that.
Yeah. That's very important also. Not only the ability to create the block, but also the community level of trustness.